What are you doing, GitHub? I'm pretty sure I clicked up here. Alright, here we go. Going to put that one in my chat, pin it. Actually, I should edit that one. Can I do that? No? I can retract it. But I wanted... Okay, this YouTube chat is annoying. Let's try again. So I want to put a space in there. So Shift Enter does not put a space in there. That is so annoying. Okay, so I guess I have to be stupid. How to send multi-line message in YouTube chat. YouTube chat insert line break. Doesn't seem to be any answers here. If you want to follow along, right, and then we pin that. Alright, I think we are ready. So welcome to the stream, everyone, and this stream is more or less like co-working, a live co-working session. I will be talking about what I'm doing, but it will probably be hard to see what's on my screens because it's small. In the future I may do this differently, but for now this is more of a background stream if you want to feel like someone is there, someone is working, someone is doing something. You could turn off the sound and put some music on, or maybe you'd enjoy having sound in the background. That's subjective, I guess. So in any case, I hope you enjoy. Oh, and I should probably inform my Discord constituents. Right, that's done. So what do I want to accomplish today? I've written something here. I don't really like that I need to check for condition types in many places. Maybe I could simplify things by having a specific condition for that. But now we'll make an ugly splitter function. Split sequence by condition. Oh yeah, this is the wrong project. So in this project, I have put a lot of stuff up here. A lot of stuff. And most of this stuff is not really, shouldn't be here. Like this is supposed to just be a test that runs here, but currently I've added a bunch of features here that should live somewhere else. So I think that the first step right now is to go through this and move these things out of here. So here we have some nodes for the template processor. I feel they should live in template AST, but we have other stuff there as well. I think the distinction here is that we have nodes in different state of of processing, and I kind of wanted to keep them different. But I don't know if I should do that, because that might be different in different situations. In some situations, maybe a code block is considered a completely processed thing, and in others not, because a code block, maybe it could have unprocessed contents that need further processing. And these structures aren't trying to enforce any of this, these are just keeping it. So if we want to know whether something is processed or not, we'd have to use another way of marking them. And I think that adding some sort of processing cache to the processors is one way of doing it, or adding a condition where we can check some property. It could be like a symbol property. So I think I'll want to move these to here. So template node here is an unprocessed node. Actually, these nodes here are pretty specific. So we should have like an abstract base node. Abstract node. I don't know if nodes should have sources here. I feel that that's a different responsibility. I think that we'll going to attach the sources in a different place if we want them. I wonder if we use this anywhere. This seems to put a source item on here. It does. Yeah, that seems to be the only place we put a source thing in. So later we'll add a way of attaching sources to things, because that's something we may want to do with a lot of different situations. So it's kind of silly to have everything support that by default. So this should extend abstract node. And this extends abstract node. Let's see, these have constructors, so we need to do super. Extends abstract node. That should probably work. So now we can remove those from here, which will break things. Is it TAST? Yes. object.assign. That's on line 5. That comes from line 9. Oh yeah, we need to call super here because this one extends abstract node. New text node. Alright, yeah. Text node. Oh, we have a lot of those, don't we? Do we have more? Alright. So now we're back in business. We want to move some other stuff. The requirement state. I feel that's sort of... I think we want to have that in data, perhaps. But in data we have different things. We have rules, operators, matches, stack, and so on. Conditions. Let's make management. So we'll import enum from there, I believe. So now we'll import requirement state from lib data management. Already been declared. That's true. We just did it. And then I feel like this function here should also live here. I think we should have an if not allowed here as well for future things. Utilities. I mean, it's not really data, it's more operations. Operations callback. Run callback, like that. Export that function. Did we export this function? Yes, we did. Check requirement state. So we'll import that as well. Still works, good. Resolver match was what we wanted to use for source tracking. I think that's only used there, right? So we could put that on ice for a bit. Let's make a planning directory. Node processing. Node processing, source tracking implementation. Currently we do not have source tracking as part of the abstract node system. I initially let the node system bear this responsibility, but is not bear, it's like, is it bear? I'm not sure. Well, we'll fix it later. I initially let the node system bear this responsibility, but later I figured this should be a separate concern that may depend on the context. Here is a previously used snippet, and then we need to also see where we use that thing. Solver match. This snippet was used in conjunction with this one. The plan here is to run things through a filter that will attach the source. Maybe something like return new TAC dots something attach source tracking some source info. In this case, I do need to mind the language here. Attach source tracking is not a filter, it is an operation that mutates its target and returns the same reference of what it mutated. This is useful for inline operations, but I do not know what we should call this. Actually, we'll ask ChatGPT about this. In my project, I just entered the following comment. End of comment. Question: what should I call functions that return their first argument but may or may not mutate things? Inline operator. That's a great naming puzzle, and you're right to think careful about it. You want to communicate side-effecting operations that return their input, usually for chaining or inline application, without misleading the reader into thinking it's a pure function or a filter. Goals for name: it signals this function acts on an object. Well, it may act on an object. Returns the same object. may mutate or decorate it, suitable for inline use. Well, I guess ChatGPT is focusing on this specific function. But I think I'll just call it inline operation. I think I will call it inline operation, but the function itself could use attach, like in the suggestions. Let's call it inline operation. All right. So now we have gotten rid of that. Where is this context symbol being used? All right, when we evaluate settings. All this stuff has been replaced with the factory function for creating block rules. This one needs to go into the template system somewhere. Templates, AST. What else do we have in here? We don't have anything else. Rule factories. Oops. I guess we can just... Don't I have functions for just selecting this whole function? I should add a function for selecting a block or a function, or I guess it would be based on the indentation. What would you call that? A section. Okay, so this thing uses all kinds of stuff. For instance, it uses the requirement state and check requirement state, which would reside in data management, I believe. What else? We use regex stuff here. So we can probably get rid of that one now. Regarding the regex, I've been somewhat conflicted in the naming. Here I'll add regex underscore for things, but I think actually what we want to do is that we want to import these things as Rx or something, or RE perhaps, and then we can take all these things and do RE dot instead, so that's more consistent, I believe. Oh, and this one would be in there, I believe. We'll notice once we try to run this. Do we have other external thingamajiggers here? We have the resolution rule from R, which are from libdata rules. Oh yeah, it's like that. RAR. Yeah, let's try this, see what happens. So instead of all this, we'll do something like we have the create block rule there, so we'll import create block rule from templates rule factories. This will never work. Factory. Create block rule. Oh yeah, we didn't export it. Conditional number entries. That's a sort of a special thing. What does it do? It's used in rule factories to assign numbers to things. That's a terrible name. It should be something like attach sequential number by something something or another. So here we use it type used, name used, settings used. So that's a conditional sequential numbering. Create conditional sequential number map. Let's not call it a map because map is a specific object in JavaScript. Let's call it a LUT instead, lookup table. And this would be a data thingamajig. I feel it goes into management, but maybe we'll move it to some other place later on. So we'll have that there. And that needs to go into here. Import from data. Oh yeah, it can go up here. C. Yes, we do need C. That seemed to be working. Very nice. We can probably clean up a little bit here. Do we use TP? Yes, we do. Do we use O? Yes, we do. Do we use R? We do. Do we use C? We do. We use TAC, I'm pretty sure. Yes. And we use create rulebook. I guess we use all these things. But it's become shorter. I should make a check-in here. Moved features into library from testing in regards to template system. I should go and get something to drink while I ponder my next step here. I guess cordial and coffee is a poor substitute for breakfast. So I should probably at some point make some lunch. Probably. So we're creating a template here, but there are some things we're not doing. Like we're not processing this text node. Here where parser is null, it should just that should be easy, but we haven't implemented that aspect of it. And the question is, should that live here? Well, probably not. This is an experiment. And I'm not sure I like this setup where I assign all these things. Like we could instead have a context and use the context. Or we could have a parent or a mapping or something. I'm going to vibe this. Actually, we can just copy the entire file path here. Please read this entire file. Otherwise, we'll just try to find relevant parts and fail. Currently, I use a bunch of symbols for all the different resolvers, renderers. But this feels clunky. I am pondering alternatives. One, use closures. Two, assign direct I guess these are alternative. Two, use a single symbol property for the operations table. Three, okay, so closures using a single symbol table. Instead of symbols, just use properties. Use property names. I don't really like free. And the problem with one is that I can't change things. Like if I want to recursively do something different, but in such a case in which I should use a stack system. Analyzing. Here is a breakdown of how things currently work and some thoughts on your dilemma about how to handle different resolvers. You are using symbols like context symbol and likely other things like title, render, border. This has the benefit of being collision proof. You have lots of these symbols scattered across modules. You need... Okay, so it's... I forgot to read what this list is. This has the benefit of being collision proof, but it's awkward when. If they're scattered, if you need dynamic dispatch... yeah, I'm not sure that is a big problem though. You want to debug inspector, so I don't think that's a problem either. Closure. Great creating local dispatch logic on the fly, hard to reconfigure at runtime, bad for recursive dispatch, hard to introspect or debug. Single symbol key and resolve a context object. Resolver dispatch. Yeah, that's pretty good. I think that I'd probably go with option 2 here. Dynamic names. Yeah, I don't know if I agree on this way of doing it, but if we need stacking, we'll just add stacking at a later point. Dang it, why do I always get so hungry once I start streaming? It's like my streams are supposed to consist of long lunch breaks. But let's implement the dispatching table first. Dispatch table. And then we'll create the dispatch table down here. We should actually use a function for this. Create dispatch table. Dispatcher. Well, I guess we create it. So okay, so we create the dispatch table here. Which is just these things. Though here they're all called renderer, so we could take this opportunity to call them different things. Just call them body array, body element, title, template. Now we need to go through these and assign this dispatch table. Target of object.values dispatch table, and then target dispatch table is equal to this new dispatch table. And we should make this into a function. Attach dispatch table. So instead we'll do attach dispatch table like that, and then this thing will do this. Like that. That might work. Now of course it will be upset here because we don't have the things. Object values dispatch table. Object tabel. That's not what I was thinking. Alright. Body element array renderer. So we have a few different of these old ones. Okay, I want to search matching case. I actually want to do... Okay, I want to find all. What is that? Is that like Alt Enter? That didn't work. No, wait. Control F. That stuff. Find all. Alright. So instead of resolver this thing, it should be dispatch table dot, and we were doing body array. I guess the dispatch table could be a closure that we could adjust. Maybe if the dispatch table is a closure. So many green checkboxes, we just have to go with this one. So in that case, we should do dispatch table and in that case, do we need to do this? I don't think we need to do that. No, we don't need to do that. We only need to update the table. How do I update an object? Assign, alright. Object.assign dispatch table. And in this case, we want to do dispatch table dot body element. Then we have title renderer, dispatch table dot title, and then we have template renderer. It's not used anywhere. Oh yeah, we use it like that. We'll use it like that instead. Does this work now? It does work now. And it is better, I think. Replaced awkward symbols with a dispatch table in a closure. We need to start to put like this resolution stuff in its own thing. Yeah, and we need to have a way of deferring warnings. We should probably put this entire thing here into its own module. But what module would that be? That would be under template. That would be like this is like an overarching thing, or the main thing, or the processor parser. I guess it's a parser. Oh yeah, that reminds me, we have parser stuff here that we need to look into as well. I don't remember the state of this, but I think it was in a good state. We'll get to it. We'll get to it. I don't know if we have parsing stuff here. I guess we have a generic parser. Yeah, we do have some parsing stuff here. I think that's actually taken from here. Yeah. Okay, let's take one rabbit hole at a time. Good luck with that. So yeah, so this stuff here, we just want the dispatch table essentially. Import dispatch table from lib templates parser.js. So yeah, it doesn't have dispatch table. Export dispatch table. Yeah, I guess these could be private because we do have access to them here. We need R and C, I think. Yes, C and O and TAST. Can't find AST. Don't we have AST here? Yeah, there it is. Oh yeah, dots local yeah, relative paths. We don't have O. Operations, operators. Template is not defined. Oh yeah, that's a new one here. That should probably be inside AST as well. Or maybe that should be more of a top level object. So let's call it types. Template from types. We can remove template here. Template resolver, is that something we're using? TP. That's from text processing. No, that's from text process. Maybe I should call this processing. No, that's tree processing. Tree processing. What are we outputting that stuff? Is that in... Oh yeah, we have stuff there that we shouldn't have there. Template from string. Yeah, we need to import template. Import template from templates types. TP in types. Oh yeah, so let's see, we're getting lost here. TP, and this one uses template TT resolver. Where should we put this thing? This one will resolve like when you have a template embedded in something else. That's the wrong project. Template TT resolver, that's in types. We have the parser. This is actually the renderer. Text renderer, markdown renderer. I feel this is sort of going to be a markdown renderer, but it's not complete. Note, this is not. This is based on some testing, and I have not yet decided if this is going to be markdown or plain text or whatever. It will mostly be here for reference, and once we need markdown or something else, we we'll cross that bridge. So the resolver should be in the parser. It also uses O and C. It uses template statement resolver. This is the TT, so that's like the embedded resolver. I should call it template embedded. Embedded template parser. Like that. Could have a similar, we'll use a closure for the table here. That would be like, yeah, like not a dispatch table, but like a parsing table that we could use. So what's the next step? I guess we move this thing. Yeah, that dispatch table is from, so we should call it rendering. Dispatch table as rendering dispatch table from markdown renderer. And then we should use that thing like that. Template TT resolver. Where are we? We are in types. Was that this thing before? Embedded template resolver. We'll export it like that for now. R.resolution rule. TAST. Context symbol. Alright, we are getting close to having this moved. Context symbol. We'll probably have that in types. Export context symbol. And then we have context. Export class context. This is the default context. Where are we actually assigning it? I guess we assign it somewhere else. This resolver should also move here. Export const template statement parser. Here we have the context symbol as well. So we'll import context symbol like that. And there we have default context, which I guess we should set up here. If we should have a default context. Or maybe that should be... Let's make a context.js and we'll move this one. Actually, we'll move these two. Context. Maybe template should just be moved to parser. Let be there for now. Create block rule is not defined. Context is not defined. Oh yeah, context not defined there either. Yeah, this is work in progress. Default context. It works. Now we can probably remove a lot of stuff here. I don't think we need any of those. Or that. Or that. I think we need that. And that. That's all we need. That's pretty nice. We can probably just assume this one to be finished then. So let's check this in. Moved out the template stuff to the proper place in the library. So the question is, what is the next step from here after lunch, of course? Wait, is my frying pan in the dishwasher? That could be a problem. I'll go and look, and in case it is, I'll just have a sandwich or two. Ah, it's too big. Something like that. It should be up there. On top of my face, like that. Ooh, nice, the dishwasher is complete. That changes things. I need like a Torx 25 or something to secure the handle a little bit. But I'm too lazy to do that right now. I have some potatoes and eggs. I guess I can take some meatballs from the freezer. So let's start with that. Maybe I should move my my audio transceiver because I get a bit of poor reception over there. Of course, I have no idea how it sounds from the other end. But maybe that helps a little bit, raising it a bit, putting it on a can of pepper. A jar, I guess jar is the correct term. These meatballs are frozen, so it'll take a little time. The potatoes are already cooked, but I'll probably just add them right now too, so they're well fried. That's nice. That one potato looks really weird. Let's remove it. Too bad I don't have any onion to go with this. Oh, I should put some spice on, some smoked paprika. I guess it's called bell pepper. It smells like old wood and animals. I don't know. I like it. And now I'm out of it. I need to buy more. So while that is frying, I know I can't leave it and go coding because that will create an incident, but I can try to tidy up a little bit here. I have a bunch of one-time use wipes that I never use, so I figure if I use them I can get rid of them. I've splattered like chocolate sauce all over the place because I dropped a whisk that I used to make chocolate sauce. Looks like I have really big flies that have been shitting here. Take quite some effort to scrub the chocolate sauce from these panels. But if I do a little bit now and then, eventually it will be clean. I'm using a cleaning regimen that I made myself with 2-propanol, water and a surfactant. Works pretty well. Because the 2-propanol will dissolve some fats and stuff, while the water will dissolve other things like water-soluble salt crystals and what have you. So it works together to take all kinds of dirt and grime. And it has that nice industrial smell. Ah, I didn't shake the frying pan often enough. And those two meatballs are still stuck in each other. Come on, separate. There we go. Some of these things that's on my like kitchen cabinet doors, I don't know what it is. It's like really hard. Like if it's like a spilled cyanoacrylate or something on there. This might be chocolate sauce though. I guess sugar hardens, become pretty hard. There we go. I guess one could make a case for gelatinous cleaning agent because you could put it on and let it sit there. Though mechanical scrubbing seemed to be the best way. Yeah, maybe, guess maybe the meatballs are being done. Hopefully they're not cold inside, but I need to put an egg on here too. I'm so hungry, but soon I have food. Soon. I need to flip that egg. I think my frying pan is slightly too hot. It's hard to do two things at the same time. Well, it will have to do something like that. That'll be done enough, I think. Nice. Now I have food. Almost getting a bit cold in here. Actually, I should probably mute myself while I eat. Well, I'll try to not chew too loudly. Yeah, they're not cold inside, they're just lukewarm. think I made too much food. I'm getting really full. I better make some coffee. Coffee is needed. Oops, wrong button. That's not the coffee button. I don't have a coffee button. Right, let's make some coffee. Coffee, 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 coffee. step 1, get hot water. I guess then step 0.5 is get cold water. And then 0.75 put said cold water on heating. Then step 2, clean the press. It's called the French press. Clean the French press. Because it's disgusting from its previous use. I really like that I can take it apart and clean all the different pieces. I don't think you're supposed to be able to do that. On some you are definitely not, but I think that's a feature. It's funny that if you take the French press container and you rinse it, even with a surfactant like dishing detergent, it will still leave like this stinky oil inside of the container. So you really need to use a brush to clean your coffee container. Or like a dishwasher, I guess. Prolonged exposure to chemicals will work. But quick exposure to chemicals is not enough. The water is boiling, that's good. I've almost cleaned the container. Right, clean enough. Step 3, put coffee grinds into the container. Well, I guess step 2.5 is put the container into its holder. I'm not going to make that much coffee now though, because I did have coffee quite recently, but I do want some postprandial coffee. Then pour some water on this stuff. Mix it good. Insert the press. Get a mug. All right. I've got myself some coffee. Looks delicious, doesn't it? Alright, so what's the next step here? We do have a template and we have like a rudimentary processor that doesn't do all the things. And one of the things we want to do is the ability for these inline expressions to exist. But that also includes the ability to have these types of expressions to exist. I do feel I'm losing some of my focus, but hopefully I'll get back on track soon. Yeah, I do need to take care of that inline parsing. That's the next step. And this is happening in... I know that we yeah, here, actually parse the title using the template parser. Because now we just include the title here as the template node. So I guess we should start perhaps by making a test that focuses on that. So that's template basic, but let's do template title. Ah, I misnamed it. Template title. Template title. So in this case we want to do, can you use this example? And this is where we want to use our parser. We'll exit one here so that we can see the output. Currently I'm using my testing system for this, but of course it could be better to just have set it up in like experimental mode where it doesn't do all this other stuff, but yeah, it works and I'm lazy. So we do have some parsing stuff here, generic parser for instance. So where are we using that? XML processing. Yeah, that's a different parser. Doesn't seem we have any examples using this. What's width? Oh, switchable iterator. Yeah, so I guess we can check if it's in the library. Formats, XML processing, data rules. So much stuff. Let's do. I keep forgetting. What is the flag you give to negate I to grep? What? I thought V was negate the result, not the case sensitivity. I guess we have examples here. of how to use this. Or so I would think. Parser language. Parser language. How far did we get at this? Okay, we have an EST there for the parser language. Parsing context, inner tokenizer. If we could get the parser language to operate, that would be a great step in the right direction. So let's work on that. Text reprocessing templates, and we'll have parser language. Parser language, which will be PL whatever. And let's delete that file, create a new one, call it plbasic.js. And here, well, we'll ignore this thing for now and instead put it there. Okay, I distracted enough. Researching someone else's problem. Computers are nothing but trouble. So quiet on Discord. I guess it's day here in Sweden, but a lot of other people are asleep. I guess I don't hang out with that many Europeans, mostly Americans. Alright, so what's next? Yeah, I should probably update this. This feels like a big step. Parsing language. I guess it's a parsing language MVP. Or maybe proof of concept, I don't know. Let's call it MVP for now. For now. And we do have this example here that we can start from. So we need to set up. Oh yeah, this is the thing. With the parser language. I mean, that's somewhat deep rabbit hole. And I worked on formalizing it, I think. What's this? HTML template? I think this is sort of a proof of concept of how the parser language should work. And I think here is one part of it is that this thing required the tree processing, which we have now done. So now we are better equipped to do this thing. But it is a bit of an undertaking, but I think that it will pay off. And here initially, so here initially we have some like an example, but we'll make a different example. What's a good way of visualizing this? Maybe Pascal? No? See? Ah, too bad you can't preview the syntax. Because sometimes you have syntax that doesn't really, it's not an existing syntax. But YAML works pretty well here, so we'll use that syntax for this. That actually works very well. So what do we want to do with our template language? Initially, we just want a very simple thing. We want, so you need to decide a few rules here. Tokenizer, basic template language. And here we'll have template statement, or let's just call it statement, which will be a sigil followed by anything. Anything as statement. There is an optional space here that I think we want to have there. This comma here is mainly for readability. Commas will be optional in my parsing language, but they are useful for readability. And then we terminate the expression with the semicolon. Optional space is a tokens. What? Oh, just because it's... Okay, so... indentation 4. That's better. I think it inherits indentation 2 from YAML. Optional space, anything is statement. Optional space, that is S, like that. And if we want to capture it, it's like that. Anything as statement. So that means that we'll get a statement match that contains statement that is the actual value. Or we should call it value. Yeah, let's call it value. And this is the basic template language of when a template is embedded in something else. So it would be basic embedded template language. Let's call it basic. Let's call it basic. But we'll make a group here. That is basic. That's template. Okay, group template. Then we have group temp.embedded. Alright, template.embedded.basic. That's fine. And then we have the title. That is statement. Then we have title. Well, we have expression, which is left double arrow anything as value, right arrow. Why is that one not red? I guess this language isn't completely I guess YAML isn't completely compatible with my parsing language. So here we have statement and expression. Default token is called anything. Anything is value, expression. I guess then the trick is that a line of something will contain expression and text. But that means we should parse it with this and a fallback. This will be the only valid option for now. We could add more things here, and if we add more things here, yeah, so this is also like, this is embedded basic. This is not embedded here. This is embedded basic. Maybe we should have basic out here. Template.basic, embedded. And then we'll have contents or like definition. So in a definition we'll have an expression like this. Or a body. Embedding body. Yeah, that might work. Language definition. Now we need to actually parse this. We'll use a generic resolver with tile conditions. Something like that. PL parser. Parsing language parser. That's a terrible name. These are just examples. We need to import O, which we probably have done somewhere here, or not. That will be from lib data operators. All right. So we need to add a rule here. And yes, we can use the block rule creation tool, I think. Because this factory include type, include name, include settings. So if we have include type, we add the type there. So we can say that include type is not something we want. So that would be not allowed. Include name will also be not allowed for things like tokens, while it will be allowed for groups or even required. Include settings. Oh yeah, We'll not allow that either for now. Ignore case will be true. And we can use this with the tree processor, right? Generic resolver. Oh yeah, but I think we can use it with a tree processor, because here we have resolution rule, title condition, regex condition, and here we have title condition, regex condition. Though why am I using it with generic? I guess it only depends on how it traverses things, so that works, I guess. And later on, if we change it, we can just add something to like a factory function in here, a sub-factory function for the factory function. Is that under template? Templates, I guess. And the tag here, also the handler here. That's the format of the handler. Tokens. Console.log found tokens. Requirement is not defined. This is true. Include name. Maybe we should make this a bit more clear. No prefix capture. No name, no settings. Now we need to actually use this. So we'll use it. Is it process node? Process text. Language definition. But we don't have process text. Tree processor is from operators. Process tree, process node. Process text. Text. This. Process tree. Then we need to create the text. That's from tree processing. Oh yeah, that's TP. We are in data operator, so that probably works. TP dot node from string text. That might work. Here we go. Fail to resolve. Yeah, this output is not very helpful because it doesn't show the title of the thing, which is the most important bit, I guess. We could, of course, remove that and see if it worked. It worked. It said found tokens. Why doesn't it say that now, though? Like, shouldn't it say that? Even if that stuff is there? Found tokens. What if we have another tokens? Tokens stuff. It only finds it once? Okay, we have some weird issue here. That's the second one. If we remove that one, then it's the first one, so it's the lost one. So it's using process 3, but maybe it should be node sequence. But that would be the same thing, right? What if it's process node? Then it fails? Oh yeah, we may need to... I don't think it's like that though. Okay, so let's take this one step at a time. Why doesn't it print this stuff? Oh yeah, it does. So dot title. Is that null? It is null. Body dot title. That's the first one. So it should possibly be that we create the node, then we process the body as a tree. That is the correct way of doing it. And now, if we add this, we should have an error, because we haven't done group. Group, which has a name, required, no previous captured, required name, no settings. Found group, group args. Unexpected end of input. That's unfortunate. It's not that one comma there, is it? No, wait, it looks weird here. What have we done? Okay, so here the name contains a dot, and I think that this might have to be a setting for our rule factory here. Include name. So here it uses W, but we could have an optional thing here. I feel I'm messing it up. So this is the original one. I don't think we can have half a thing like that, but we can have it if we process it as text. And also we can push multiple things here. Name pattern. So name pattern can be here, which can equal. We have so many settings here that I kind of want to make it into an object instead. To do, we have so many settings here. We should make it into an object. Maybe even a configuration object, configuration schema object. So name pattern will be W plus here. That's after ignore case. Ignore case, and then name pattern is W and dot plus. Required name, no settings, no case sensitivity, case insensitive. And include dotted names. Oh wow. So much error. Is it failing at the first one too now? It is. But what if we don't do this? So something changed the way we created. We have messed it up. I say we, but I mean it's just me. I have messed it up. Do we have name pattern? Wait, what's that thing? That's so silly. Pieces, group, optional colon. Then we have, we start on, what? It's an S there. Oh yeah, because we need to double escape the S, of course. And now it works. Very good. Maybe we can take these and make them into pre-configured little bits. Concrete statement. Actually, we can make functions. I think that's better. No, actually, I changed my mind. I keep changing my mind. Const concrete statement settings. Then we have dotted name statement settings, which are these. And we can explain them here. Okay, so why is it angry? Because we don't have that thing, alright. So now we can use these here. And here we use the dotted name statement settings. Works. then we add this thing in here. Does not work because I make weird things. Alright, found group where the name is template.basic. That's very nice. Very nice. Then within this group we have tokenizers, which could also be outside of the group. So here we'll need a stack where we say that we're in this particular group. So then we should have a function to manipulate an object based on text. So let's try that first. Write path const ob equal hello world, just to have something in it. Write path ob this is a test 1 2 3. And then we can write hello.world 456. The problem here is that hello is already a string. So that should fail, because it should make sure that it's an object. Though isn't everything an object? Maybe we should just not, maybe that's not our concern. Target path value for, okay, so let p_r equal target for const name of path.split dot p_r equals p_r name. If p_r is undefined, then p_r well, okay, yeah, we should do if p_r name yeah, let's do it like this. Const pending equal p_r.name. If pending is undefined, then p_r, that's a weird p, p_r name equals a new object, and then p_r. Okay, I wonder if we do p_r name equal p_r equal that thing, will it first assign that and then that? Let's ask the Silicon Oracle. Will this update from the left so it doesn't break p_r before updating p_r name? It will complain that it's hard to read, I think. Okay, it doesn't complain. I thought it would say that it's like bad karma or something. So if pending is undefined, it will do that. Else, it will just assign p_r to pending. But this is different also, because if we're on the last piece, then we need to do something different. So I need to go through everything but the last piece. So this will be the head. Pieces is path.split, alright. Head final name. I'll just be lazy here. How do I put everything but last element in head and the last element in final name? Oh, we pop the last element. Const final name equal pieces dot pop. So here we'll go through pieces in order to get to prepare PTR if needed. This may be not needed. Then PTR final name equals value. That should work. Cannot create property world on string world. Yep, that's correct. I sort of expected that one to fail, but that's fine. Hello.world or hello world. This is a object. It's not an object, it's a value. I guess it's just too deeply nested. Blarg.thing 1, 2, 3. Alright, that works. Let's also do get path or read path. Failed if it doesn't find it. So we need to implement it, of course. Read path, target path, default equals undefined. What? Can I not do that? That's a token? What the hell? Silly JavaScript. So I set PTR to target. Here we can actually go through all the pieces, I think. Then we just return PTR. Or rather, if PTR is undefined, return default value. Else, return PTR. PTR. Come on, keyboard and fingers. PTR. And here we can also check that, oops, if PTR is undefined, we just break because there's no point in continuing here. Oh yeah, here it tries to go into something that is not possible. Can we try that? That's not how try works. Well, we shouldn't be assigning here anyway, because this is a read thing. So it should just be ptr equals ptr name. And this is just an early return. One to three failed. That looked good. This should be like a generic data function, I think. Conditions management stack. Let's make one called object.js. We'll export these two. And we'll remove these two. And we'll import them. Read path, write path, data object. Looking good. This is going to be used in order to set up the nested groups. Yeah, we tested the path stuff there. We have identified group stuff. We need to put groups in on a stack. So we need to create a context. And I don't think we create a context by default. So we'll use the context thing. I'm not sure default context should actually live there. Should probably not be in here, since this may not. Also, context should probably not live in templates. Yeah, I think this should probably live. Okay, to do move these up a level or to data or something. And then this should probably be the only thing in here. See preview, see comment at context symbol. Does that work? We haven't tested that. Maybe that shouldn't work. Right path, ob, empty string, yo. Oh yeah, it just treats it as it should. Right. Path stack. We use it as a list. And I think maybe we should be able to add lists here too. So we could do blarg as a list. That will fail because we can't split that. So that should be a flattening function. Read path. We export it here. Oh, it's like that? Yeah, it's like that. Must be string or array. For sub item of source. Yield iter split sub item separator. And here we have yield star source dot split separator. Is that all we need? Must be string or array. Got. What did we get? What did we get? We got source. We got blarg.thing. Isn't that a string? Maybe that doesn't work. Maybe we can't do instance of string. Does this not recognize string literals as string instances? Correct, does not recognize string literals as string in. They are primitive strings. It's so terrible to have to see if it's a string, I think, but I guess that's how it is. Type of source string. So here we write blarg.thing 2123. That seems correct. Here we read a few things, that's correct. Then we write yo into this list here, which could also contain a sublist with thing. Blarg thing 123. Blarg thing yo. Did I spell blarg differently? I did. Yeah, we overwrite thing there. That's also a concern. What if we overwrite something? What if we define the same group twice? What do we do then? Do we add to that group? I guess we could do that, but what if we define the same tokenizer in that group twice? I guess we could do a read path to check, or we could add a strict flag. So we can have an overwrite here, we can have not overwrite there. Overwrite equals false. Though how do we know if we overwrite something if it's not a plain object? I guess that's hard to. We shouldn't put that concern there because it's hard for us to know at that point if it's valid or not. So we should check it where we are actually adding it. And one thing with write path here also is that maybe we should be able to supply a constructor for whatever object we are using. So let's do a new one where it's like new path dot path, and we do hello world, and then we use a function here where we have the name. So we could just return an empty thing like that. And in this case, we'll return, let's say underscore name equal name here. Now we just need to implement it. Construct object constructor equals object. It's just an empty thing like that. So here we do object constructor name. Will that work? Oops. Name more. Yeah, that works. I guess that's a silly example, we don't need that. Though here, oh yeah, because we didn't create the first one, so more long path. Name more, name long. Yeah, that works. That's very nice, I think. Because then we can have a group object. Though I guess another problem here that we may want to solve is how do we actually write to something? Because now we're just setting the thing. But that may not always be what we want to do. So let's see if we want to first. This is getting a bit messy here, so there we go. Write function will equal to target name we'll do write function ptr name object constructor name. Then ptr need to be whatever we wrote there. And we can have it return what we wrote. Return value. So it's an inline operator, I guess. So that works, but then if we do something different, we could have other long path where the write function is target name value return value target name. Yeah, we just log it. Log name value. log. Log other, name other, log long, name long. Yeah, that's pretty good. I guess now we need a read function for read path. Which we would need here too then. Okay, this is getting to the point where we should just create an interface function that we can use. Path-based interface. Static separator. Is it like that? Read target path. So here we should have ptr equals this dot read, or like get read get child ptr name. Get child target name, which normally just returns target name for the object interface. Constructor separator object dot assign this separator like that. Set child target name value. Target name equals value. This dot separator. Get child ptr name. Right. Default value. Default value undefined. Now we get to the right path stuff. Right, target, path, and stuff, probably. So here pending is this dot get child ptr name. So if it doesn't exist, okay, so here we need to do this dot set child ptr name, this dot create child name. Then ptr needs to be updated to whatever that value was. New child, const new child equal this create child, ptr equals new child. Alright, that looks good. Then here we have an update, which should also be this dot set child ptr final name value. Looking good. Now we need create child, target, no, just name. Maybe parent? Yeah, let's have parent as a thing there too. We can have it there as an optional thing. So it should be create child name parent equals undefined to indicate that this is optional. Here we just return a blank thingamajig. So now all we need is this path-based interface. Value is not defined. Now I should probably include value here. This.is.path, that works well. But then if we have the group interface, for instance, so we could have groups, new group, or like root new group, which is called root. Class group, constructor name parent equal null, because it could be the root. Object dot assign this dot name dot parent. Then we do, so this is the root group here. Yeah, let's do instead that we have cons root equal the group there. Path-based interface. Group access interface extends path-based interface. Const guy equals new group access interface. Let's call it group access interface, like that. And we do group access interface dot write root path to thing. And I feel like here the final value should be optional, because if it's not defined, then it's just like a new child. If value undefined, else. So if it's undefined, then we create a new child here. This.create child name Peter. Okay, now it's getting messy here. That might work. Name is not defined. Yeah, because that's final name. Group, name, root, parent, null, path, to, thing. Yep, that almost works. Group should have parent, children, equal, new object. Then in the group thing, we need to override create, get, and set child. So get child will return target.children name. Set child is target.children name equals value. And create child is new constructor. Or is it this dot constructor? This constructor name parent. Okay, so it tried to read. Oh yeah, because it read path and it didn't get anything. So that means it needs to create all the sub pieces even when writing, but it's in during the reading. Shouldn't it be creating it here? Path pending. That's undefined, alright. Group access interface. Oh, why? Oh, okay, so that's a problem. This constructor, that's not right. We're not creating a group access interface, we're creating a new group. Group root. Okay, let's inspect. Group name root, children. Reference number 2, group path circular 1. That's the parent. Parent here is circular 2, circular 3. That seems to be correct. Root.path to thing. I think this is a good way of reusing things like this. This is the group access interface. Then we'll have yeah, this one should make sure that this one is empty. Undefined. So if it's not undefined, then we'll create a problem. name or name already exists in group target. So if we then try to do this again, thing already exists in group. Yep. I guess sometimes we have a way of getting a path, but we don't always have that. That depends on what data model we're using. So this thing should have get path target, and it return null because we can't get the path. Not supported for objects. But we could do, it could be this dot get path target and then fall back to target.name. But because we have a path here, we can do get path target. If I guess we do, yeah, if target dot parent return target dot parent dot get path dot target dot name. Else return target.name. GetPath is not a function. This is a function. What is target.parent? So that's a group, right? It has a name. Oh yeah, we don't use getPath on the thing. We use this.getPath target.parent root.path.to. Yeah, that works. Nice. And this is a generic group thing. Okay, the static name equal group. Why doesn't this.name work? Is the constructor.name? Prototype.name. This.constructor.name. That works. So we'll call this basic tree interface, basic dotted name tree interface. But here this is called node. And this extends the basic dotted name tree interface. Very nice. And this thing can then go live over here. And we can import that from here. Groups not defined. Did we put a group in here? Yes, we did. Create child. Create child will always have to be specified. We can't guess that one. Create child must be defined. So that's the one thing we need there. Ah, looking good. Ah, my freaking back. headphones disconnect? Why did my headphones reconnect? we were talking about processor temperatures, and I was like, yeah, mine is at 80 degrees right now. My CPU is using 100 watts. And he was like, you run 100% all the time though, right? Don't you have some background thing going? And I'm like, well, I'm streaming on YouTube, and I do have a background that is a real-time ray traced fractal. I guess these things cook. It's so, yeah, never get quite to the goal. Like, I want to continue working on this, but I'm also feeling my mind wandering. Where are we? We did a group thing, alright. So the next thing would be in order to actually, so if we move these things, well, I guess it doesn't have to be there. Well, it has to be on top of here. So if we'd put that stuff up here, and then this thing here, where it finds a group, which we're not doing right now. And we can remove all that stuff. So here when it finds the group, it needs to create a new group, which we do. So we'll do context. Oh, should this return what we write there? That would be kind of nice. Group, well, root. So root would be ctx.root const ctx equal resolver context. Context is not defined. Context symbol. So you have root, which would be new group root. But write doesn't actually return what we wrote, and maybe we should. New child. Return value. Something like that, perhaps? Yes. Returns child after writing it. Returns value or new child. Group thing 2. Thing 2. Path to thing. Ah yeah, that's not the correct path. That should be... Well, we should also not use root here. We should use whatever current path we are in, or whatever current... so let's do group stack, which starts by root. Can we use root like that? I don't think we can. Yeah. Root group. I think we have a stack channel thing. Stack channel. Init stack channel. Document this write test. Yeah, I'm not sure I want to use this particular one. We may get back to that. To do, possibly utilize stack channel or something else. So we have group stack, root group. So we do ctx dot group stack dot at -1, which is the top. Oh yeah, and then we need group args dot name. New group equals that stuff. So then we do ctx.groupstack.push new group. And here we need to run all the sub things. So we'll do resolver.process3 item.body, I guess. I think, maybe. And then we'll pop the group. So now we're probably failing on these things in here. Or not. It's so hard to see what we are failing at here. We should probably convert it to text. Where is this? It's in here. Do we have item to string? We don't. What about to string? That just gives us object. We should probably have an error callback here. On failed resolution. The item. On failed resolution item. Then here we'll do fail to resolve the node title. Tokenizer body. So I could do that one? That's so weird. Oh, it's this tree thing again. Item.body. Is it process node item.body? Oh, we should not process empty ones here. Where is that setting? Empty. Is that in processing? Emit untitled. False by default, so that looks good. It's weird how we'd have an empty one there. So let's create a rule for tokenizer for now. Tokenizer. It should have a name. Found tokenizer. Dotted name statement settings. Found tokenizer body. So it's not finding all of them. Okay, that's an infinite loop if I ever saw one, or recursion. Process. It should be item.body, shouldn't it? Why does it only do one? And it's the last one. Body.body works. Why do I need to do it like that? I feel I've done that in several places now, and I'm like a bit bothered by it. To do, figure out why we need to do it like this. If we do item.body, we will only process the last entry, which is a bit weird. So let's see if we can actually add this tokenizer here. And here's also a thing, we have tokens in the root here. I guess we could have different tokens in the groups, so I guess we should need to address that as well. New tokenizer. Group access right thing, the group args.name, and then the new tokenizer, which just say tokenizer there for now. To do actually create. Then we do something similar with the tokens definition table. Token table. But here we don't have a name. So here we're essentially just adding it to whatever group we have. So in that case, we should have the group stack, and then just do group dot token table tokens to do actually create. And here is a question also to do. Check what happens if we try to create a tokenizer where there is a group. And here we should inspect root group. Actually, we should inspect the context here. So here we have the root, which contains template, basic, and that contains two tokenizer called embedding and body. So that's good. So I guess here we could test what happens if we do tokenizer template. That causes a problem. Template already exists in group root. Okay, very good. Token table, tokens in root. That's good. Yeah, I guess the group stack here contains one entry, which is good. So we can be confident that root group will be fine here. Yeah, that's pretty good. I think that's probably going to take a break, do some other stuff, relax a little bit, maybe play a game, I don't know. Rest the old lump of lard. But then, what's next? I should think what's next. To do next. Implement tokenizer table and tokenizer token definition tables and tokenizers. Generate suitable create a usable tokenizer based on this. And what we were trying to do is that we wanted to do what's in so look into template title.js for what is next after that. So I think that's good enough. What did we change in the makefile? Oh yeah. Further work on trees, parsers, and the parsing language. Trees, parsers, templates, and the parsing language. Push. So there we have the latest stuff. And I guess we could see what has been done recently here. So I guess these are the commits today. So that's like, can I just arg? So it's that to that. So I think we could do how is it we view a range? Is it just like that? Oops. Not found. I think you do it in pull request. Yeah, it's like that. 642 additions, 361 deletions. Yeah. So this is what was accomplished during this stream. And yeah, thank you everyone. Thank you, you few ones, for watching. I sure hope you enjoyed, and I'll be back doing this soon, I hope.